This week, I want us to collect data from a simulation. There's a natural selection simulation. There is a lab version of it where you can have more variety, and you're welcome to play with that. But what I want us to look at is I want us to look at the intro simulation. And what you can do with this simulation, so you've got this little bunny, you give it a mate, and then these bunnies do what these bunnies do. They reproduce. They reproduce. You see this generation counter, and they reproduce at the top of the hour. So there's more bunnies that are going to be happening at the top of the hour each time. One of the things you can do is you can add a dominant mutation for brown bunnies to start happening. And you can do this at any of the generations. The other thing you can do is you can add wolves. You can also do this at any time during the generations. So you can add a wolf like here now, and then the wolves go and they eat the bunnies. And then you can let this thing run. You can let this run. You can make it a little faster if you want to. If you don't want to wait for things to happen, and then you run it until for however many generations you can run it until one of two things happens. One, either the bunnies take over the world or all the bunnies die. So those are your two outcomes. Um, when that happens, you then check to see how many generations you had this thing going. You click on data probe, and with the data probe, you can then see how many bunnies you have. So 823, that would be your total number of bunnies. So you see here the black part, that's the total number of bunnies. There are 34 white fur bunnies, and there are 789 brown fur bunnies. And you can do the simulation either in the Arctic, or you can do it. So if you start over, you could start this over in the Arctic, or you can start this over in the prairie. You can switch this throughout in the middle of the experiment too, but I would like to avoid that for the moment, just for ease of you. You should know from what we've talked about with the scientific method is we've got enough variation here already. We're gonna not try to muck this up by adding additional things. We're also not gonna muck with limited food. So what I want you to do is I have this Excel sheet here that I'm going to share with you guys. And so I want each of you to run 5 simulations and put the data here in this Excel sheet. So for example, if you choose to use the Arctic No Wolves worksheet. So click on Arctic. So let's say, for example, there's a blank here, Arctic, dominant mutation at generation 2, and no predator. So you're going to click Arctic. You're going to pause this. Well, actually, don't need to pause it. You add a mate. You let it run for generation 1. And then you're going to add a dominant mutation at generation 2. Now, to make sure that we're all sort of doing the same thing, I want you to make these additions, whatever additions you're going to make them in the first quarter of the circle. So just pause it in the first quarter of the circle, and then click your dominant mutation here, and then continue. Fast forward this until this goes to bunnies taking over the world. And then you're going to do the data probe and move it all the way over here. And so you've got adding the mutation at generation 2, no predator. The bunnies did not die. So no, the bunnies didn't die. And that's not applicable because they didn't die. They did, in fact, take over the world. And they took over the world at generation 6. And that's one of the things I already want you to notice. See that all of these things have in common that they have no predator. Generation 6 seems to be like the magical generation. 1428 is the number at which they all died. 1296 and 132 brown bunnies at the end. So they always take over since there's not a selective pressure, right? There's no reason to either. This is literally based on just the genetics of dominant versus recessive. And they take over the world at generation 6 because nothing takes them out, right? Nothing eats them. Now, the next possibility we have is to have the wolves and have no mutation added, right? So we're going to start over. We're still in the Arctic. We got the little dude here, and we can add a wolf at generation 0. Again, what I want you to do, we're going to add a mate, but I want you to add the wolf in the first quarter of this simulation, because the wolves start their activity right there. So you want to make sure that you add the wolf right before they start becoming active. And that's not important in an overall scheme of things, but it's important for the data so that we all produce the same kind of data, because otherwise the wolves wouldn't become active until the next time. So we're at generation 0, we're adding the wolves in the first quarter, there it goes, and then we're gonna run this thing. And if you add the wolves in the first generation, here comes the wolves again, and you have all the bunnies have died. So if you add the wolf at generation 0, all the bunnies die. Yes, they died, in fact, at generation 1. They did not take over the world. This is not applicable. Total number of bunnies, because they all died at the end, right? Total number of bunnies at the end is 0. And like I said, so I want you to do 5 of these. Pick 5. It doesn't matter which 5. There are a number of different, so you can do the wolves with the dominant mutation. So, let's run this one real quick. So let's say at generation 0, I'm going to start over. We're still in the Arctic. And we're going to add a dominant mutation at generation 0 and a wolf at generation 0. So I'm going to add a mate for this little dude, pause this so that I can put a dominant generation, a dominant mutation, and the wolves at generation 0. And then we're going to run this thing. And all the bunnies have died at generation 1. So the bunnies died. Yes, please, they did. They died at generation 1. They did not take over the world. This is not applicable. The total number of bunnies, 0. Number of white, number of brown, 0. And then, like I said, so pick another one of these. So we've got the same thing for the Arctic. If you click on here, you can do the same thing with the recessive mutation. And then you can do the same thing with the prairie. And once we've all kind of filled in the data that we've got, then we can talk about what we see. One of the first things that I want you to already notice is, clearly, if there's not a selective pressure, the bunnies take over the world. There's no, and the number of bunnies, right? The number of white versus brown bunnies really is only related to the generations. Whereas if you add the wolves and you have no mutation, right? The bunnies die. And they're just gone in the prairie, right? And if you add a mutation, we're going to see what happens when you add the mutations, either the dominant or the recessive one. And like I said, fill out whatever sheet, whatever condition you want to run. Fill out the data, and then we're going to look at what we've got. Hopefully that is something that is going to be illustrative for how natural selection works.